Hello dear students. So, in the last few classes you have learnt about the ASB map for material selection, and you also have learned how to use ASB map and through which how you can select material to make advanced materials such as composite materials and cellular materials. In this class, what we are going to discuss today is basically, as you can see, the topic is basic of composite materials and classification. And in this class, what I am going to cover, initially I will talk about the applications, various applications of composite materials, and then I will discuss about the basic concepts of composite materials, followed by I will discuss about the different kind of properties what we see in composite materials, and then we will move to classification of composites based on matrix materials, and then if time permits we will talk about metal and ceramic matrix composites. So, composite materials application is versatile. Now, before I go into the application part, let me give you briefly a discussion on the composite materials. So, if you look in the definition of composite materials, what is a composite material? It is basically combination of more than two materials. Now, alloys, if you look into alloys, those are also combination of multiple materials. For example, let us consider an alloy with atom A and B, and let us consider atom A and B are of similar size and they are soluble to each other. So, let us consider a substitutional solid solution where the atomic size of the two components. So, let us say this is A, something like this, A and B are distributed. Now, here you can see that A and B are mixed in atomic scale. However, in composite materials, if we look into the microstructure of a composite materials, we have the major phase called matrix, and then the second phase which are distributed in the matrix are called reinforcement. And in this case, we can clearly see that there is no atomic level mixing, but there are two different phases. In this case, the matrix and the reinforcement, they keep their physical and chemical properties intact and they have distinct phase boundaries. So, that is a composite material. That is the basic difference between a composite materials and an alloy. So, now if we go back to the properties, I will come back later and I will give more details on the basics of composite materials, but for the time being let us look into the application of composite materials. You can see in this slide. So, you can see there are multiple applications of composite materials, starting from sporting industries to aerospace to automobile industries to power industries, and even in different kind of water vessels as well. In case of sporting industries, you can look at these particular sporting cycles. So, all these wheels and wheel bases and wheel rims are made of different kind of composite materials. Similarly, the frame of bike of advanced bikes are also made of different kind of composite materials. Similarly, the boat hull in this case is also made of a particular kind of composite materials to reduce the weight. In aerospace industry, the application is similar, basically to reduce the weight, on the other hand to improve the strength. In case of windmills, if you look at these blades are long structures and it has to be also be lighter. At the same time, it has to retain its strength. So, there is no other option than composite materials. In automobile industries, mostly in all parts you will be seeing there are applications of different kind of composite materials. I was talking about aerospace industries. So, if you look at this particular diagram, almost all components are made of some kind of composite materials, as you can see clearly here, starting from the cowl, which is basically a graphite composite, from the spoilers and then auxiliary power inlet, tip fairings, all kinds of components are made of different kind of composite materials. If you look at this particular graph, you can again see that different kind of different aircraft companies, how they are using composite materials in their aircrafts. For example, if you look at 350 model of Airbus, they use around 50%, more than 50% of their weight, of the total weight of the aircraft is actually made of composite materials. Similarly, 787 from Boeing and other different aircrafts, they use a huge amount of composite materials in their components. And as I was mentioning earlier, the basic concept here is to reduce the weight and increase the specific strength, also to increase the or to improve the fatigue properties, and in some instances to improve the wear resistance. So, basically you can see clearly here that to improve different kind of mechanical properties, whereas to reduce the weight, keeping the weight low so that it becomes energy efficient, fuel efficient, you cannot, I mean there is no other option than composite materials. Let me give you some more examples of composite materials being used. We all have heard about this B-2 stealth bomber. Now, it is having a clever design, it is having a particular design by which actually it can evade radars. So, basically radars cannot detect B-2 stealth bombers. Now, how do they attain that kind of like efficiency, and that lies in the particular structure of this bomber. So, this structure, now this kind of structure can be only made by composite materials only, okay, to have that kind of strength. However, to have this kind of particular structure with this design, there is no other option than composite materials. If we come to general applications, we all know about radial tires. Now, radial tires from outside externally it looks like just it is made of rubber, but then it has different kind of components which actually improves the strength and wear resistance of radial tires. For example, we can see here that there has been lot of different kind of reinforcements are being used in the terms of nylon cord or aramide fibers and different kind of fibers and reinforcement. Similarly, you can see here around the the periphery of tires also these bead wires which are made of steel and which are basically coated with different kind of tin or copper copper tin alloys, copper tin in some cases copper tin zinc alloys, and these steel wires which are called bead wires are also used to reinforce the radial tires. So, the point here is that I mean in all applications, in all starting from household applications to advanced aerospace, automobile, aircrafts, fighter bombers, all kind of applications if you look into, ultimately the world is moving towards composite materials. Now, I was mentioning earlier about composite material, let me come back to that once more. So, what is a composite material? As I mentioned few minutes back that it is a combination of more than one phase, where the different phases keep their the physical and chemical properties intact. For example, I was drawing earlier a basic microstructure of a composite material, where we are calling the major phase as matrix, and the matrix hold the different kind of reinforcements, and these reinforcements or the second phase could be of different shape and sizes. Here we are talking about particles, but it could be like fibers as well. So, again let me come back to the basic definition is that composite materials are basically combination of more than one phases, where one phase is called matrix, other phase is called reinforcement, and in this case all the phases retain their physical and chemical properties, and ultimately by doing this combination of different phases, there would be some kind of augmentation in certain properties. If we look into the basic definition of composite material, so the definition says a composite material is a mixture of or combination of two or more distinctly different materials which are insoluble in each other. That means, in alloy we talked about atomic level mixing or solubility of different components. In this case, the different phases are insoluble insoluble by theory. In practice there would be different cases, but in general theoretically the different phases are insoluble to each other and differ in form and chemical composition. And if we look at the different characteristics, basic concepts or characteristics of composite materials. So, the composite materials, the first thing is, yes, in nature we have existence of composite materials, composite structures, but in this course we will talk about composite materials which are generally manufactured. And as I mentioned earlier, consist of two or more physically and chemically distinct phases. Phases are separated by well defined interfaces. Okay. So, if we look at this particular structure, this drawing, and if we look at this thing, and if we then try to magnify this area, so you can think about this is the reinforcement particle and this is the matrix. So, this matrix and reinforcement are basically separated by an interface, and in the later classes we will talk about the importance of interfaces in great deal. For example, the role of interface in metal matrix composite and ceramic matrix composite would be different, and we will discuss about those. So, interface is also a very important factor in composite materials. So, as I was mentioning earlier, phases are separated by well defined interfaces and the secondary phases are well distributed. That is another very important factor here, is that the different phases, the second phases what we are seeing here, ideally they should be randomly distributed, evenly distributed to ultimately optimize the properties. And characteristics of these composites are not depicted by any of the components in isolation. That means, if we do not make this combination, if we try to use these different phases separately, we will definitely not end up in having the properties what we see in composite materials. And obviously, composites are strongly heterogeneous structures. That means, atomic level, if you look at the atomic level structure, obviously the atomic structure from the matrix to the reinforcement, there is variation. Okay. So, I think the basic fundamental idea of composite material is clear to you now, students, is that composite material is a combination of more than one phases, where these different phases retain their chemical and physical structure, and the different phases are basically separated by distinct interfaces, and ultimately by doing so there would be improvement in certain properties. So, as earlier talking about the composite, one of the feature of composite material or characteristic of composite material we mentioned is that these are generally manufactured, and I was also saying that there are examples of naturally existing composite materials. So, can you think about some examples of composite materials which are naturally existing? Right. I mean, you all have heard about wood structure. If you look at the microstructure of wood, okay, it basically contains two different kind of features. One is lignin. What is lignin? Lignin is basically a complex biopolymer, naturally existing biopolymer, which is the basic structure of wood. It forms the basic structure of wood. That means, in this case lignin is the matrix of a composite material, and this matrix of lignin is basically reinforced with some fibers, which actually provides the stiffness of the wood, and these fibers are made of cellulose. So, if we look from the point of view of composite materials, wood is a composite material where the lignin is matrix and cellulose fibers are the reinforcement. Similarly, we have existence of composite materials in our body as well. In bone structure, the bone structure is a highly composite material. In this case, the matrix is made of hydroxyapatite. It is basically kind of calcium phosphate, and this hydroxyapatite is reinforced with a fiber, protein fiber, which is called collagen. Now, we understand what is a composite material. we understand that it is a combination of two different or more than two different phases, and ultimately that leads to improvement in properties. Excellent. Now, let us look into the different properties. We will discuss about the mechanics of composite materials and other things, but before we go into all those things, let us initially look at the properties of composite materials we see. Now, if we look at this particular Ashby map, where in one side on the x axis we have specific strength and in the y axis we have specific stiffness. Now, if you look at this metals and alloys, okay, we can see most of the metals and alloys, they have a very good specific stiffness, however, the strength is not that much. Okay. How do I improve the strength? By going into the region of composite materials. We can think about reinforcing the matrix with some kind of high strength materials which would improve the strength. Similarly, if we look at the point of view from the point of view of elongation, then we all understand, we know very well, ceramic materials, they have very high strength, but then they do not have that much of elongation, okay? They fail catastrophically. So, how do we take care of that? Again, we take resort of composite material, where actually you can see here composite materials, obviously they may not be having that high strength of ceramic materials, but then it will impart some kind of ductility in the material when we make composite materials. Again, a combination of strength and elongation is toughness, and toughness is very much important. It actually delays the failure in a material. So, toughness is required, as we all understand, and we can again see that ceramic materials and glassy structure, they all have very good strength. Okay. However, their toughness is very poor. As I was mentioning earlier, they fail catastrophically, they show brittle behavior. And how do you overcome that? Again, you make composite materials of those particular materials, keeping them as matrix, and then try to improve their toughness. Similarly, in some applications we will be needing high thermal conductivity, at the same time low electrical resistivity. And again, we can think about making composite materials by choosing the matrix and reinforcement wisely to improve this kind of electrical and thermal conductivity, right. So, now we understand the what is composite material, and we also know a little bit about the application of composite materials, and from there we can clearly see there are certain advantages of composite material. For example, lower density. Now, lower density means, what I am trying to say here is that lower density with high strength. Okay. For example, aluminum matrix, okay, low weight. Now, if you reinforce that with high strength reinforcement structures, reinforcement materials, the strength improves. Okay. So, I am talking about that kind of densification, lower in densification. Okay. Like aluminum matrix, if you reinforce with SiC or other fibers, okay, density goes down, at the same time specific strength increases. The same point here has been mentioned here, higher directional mechanical properties. Based on how your fibers are aligned, we can achieve enormous amount of strength in particular direction. Obviously, fatigue endurance or fatigue properties gets improved in certain cases, and when it comes to ceramic materials, if you reinforce them with certain reinforcement, then there will be improvement in toughness in ceramics and glasses. So, we can see here ultimately, depending upon how you mix and match your materials, how do you choose your combination of composite materials, you can actually end up having different kind of properties of your own need. Okay. And there has been improvement in certain other properties as well, like damping, corrosion, these are case specific applications. And ultimately, to improve or to augment certain properties, the cost in terms of synthesis or fabrication is not that great when it comes to composite materials. So, now we understand what is a composite material, very good. What are the applications of composite materials, and we also now have a fair idea of the advantage of composite materials. Now, let us move into the classification of composite materials, right. Now, composite materials can be classified based on matrix and reinforcement. Earlier I have explained vividly what is matrix, what is reinforcement. So, basically the primary phase is called the matrix and the secondary phases, there could be multiple secondary phases, those are called reinforcement. Okay. And these reinforcements could be of different shapes and sizes, it could be like particles, okay, spherical globular particles, or this could be as in the shape of rods or fibers, okay, or whiskers. Okay. So, initially we will talk about the classification in terms of the matrix. Obviously, we have three major kind of matrix. One is metal matrix, that means the matrix is made of metal. Similarly, we have ceramic matrix and we have polymer matrix composites. Okay. In today's class, I will talk about metallic matrix composites and ceramic matrix composites. So, now why do you, the question obviously the first question comes in our mind is that, I mean, why do we need a metal matrix composite? Why do we need to reinforce metals? Okay. I was discussing few minutes back, yes, metals they have fairly good strength. However, when you try to use these metals, application of metals is inevitable because of their machining capability, because of their ductility, because of their toughness, elongation. Okay. They are and because of ease of fabrication of metallic material, metallic components, use of metals is inevitable. Okay. Now, how do you improve the strength of these metal materials? Okay. Just by reinforcing the matrix with high strength particles or fibers. So, basically the definition says that metal matrix composites consist of a metal or an alloy. Obviously, I mean metal means we are talking about alloys as well as the continuous matrix and the reinforcement that can be particle, short fiber or whisker. Now, I will discuss about particle, fiber and whiskers in details when we talk about fibers, but basically the idea here is that you have a metal matrix and you basically improve the mechanical property of that matrix by reinforcing the matrix with high strength, high hardness, second phase. Okay. You can see some examples here in this particular two microstructures. So, this is a typical microstructure of alumina fiber reinforced magnesium alloy composite. Okay. So, you can see here these circular cross sections, these are basically the cross section of the fibers. Okay. So, the fibers are basically perpendicular to the screen here in this particular case. So, here it is an example of metal matrix composite reinforced with fibers. Similarly, in the below microstructure you can see here that it is basically an aluminum alloy matrix which is reinforced with silicon carbide particles. Okay. And the basic idea is again same, that to improve mechanical strength. Okay. So, if you look at the basic attributes of metal matrix composites is that it leads to enhancement in strength to weight ratio. Okay. Its toughness is also gets improved, modulus gets improved, and thermal expansion of coefficient and all those things, you can tailor those things, and obviously it leads to wear resistance. All right. And if you look at again, I mean obviously the elevated temperature strength or high temperature strength is a major major problem for metal materials. Now you can actually improve the high temperature strength of metal or alloys by reinforcing them with second phases. Okay. The same thing, improved creep and rupture strength. And what kind of metal matrix actually composites we see in reality? So, what kind of matrix we see? All kinds of matrix starting from aluminum alloys to titanium alloys to magnesium alloys, copper alloys, intermetallic compounds, different kind of ultimately metals and alloys can be used as reinforcement. And then you can see here the whole gamut of reinforcements starting from SiC to Al2O3 to boron nitride B4C, okay, and this could be used as particles or fibers or short fibers or continuous fibers as well. And so, the application wise, if you look, okay, obviously there are household applications of metal matrix composites. In this case, we are talking about some advanced level metal matrix composites. For example, in this particular case, you can see here these ventral fins, okay, and in some cases the fuel access doors of F-16 Fighting Falcon, that is made of AlSiC composite, aluminum matrix SiC fiber or particle reinforcement. Similarly, if you look at these particular examples, it's basically a picture of Hubble Space Telescope, and in this case this particular the antenna, the high gain antenna, it's made of again a composite material. It's basically a long structure, as you can see, okay, which is basically standing like this. So, it has requirement of good amount of stiffness, and how do you, and at the same time it has to be lighter weight as well. So, again you can look at this case where aluminum alloy, particular aluminum alloy 6061 is used, and that alloy is reinforced with continuous carbon fibers. Similarly, again there are a lot of different kind of applications. In this particular case, what has been shown here is that for electronic substrate materials, where actually we look into good thermal conductivity, and you actually also do not want a very high amount of thermal expansion. Okay. So, metals, they show very good thermal conductivity, fairly good thermal conductivity. At the same time, they show good amount of thermal expansion as well, and we do not want thermal expansion to be high in case of electronic substrate materials. And you can think about different kind of metal matrix composites which could be ideal for this kind of applications. This is basically a piston, actually piston head, what has been shown here, and for supercars these are used, and you want lighter weight. At the same time, this goes to a lot of wear, pistons goes through a lot of wears inside the engine block. So, how do you how do you take care of the wear, at the same time you reduce the weight, and in that case aluminum matrix composite with SiC reinforcement comes handy. Okay. So, so with that actually we will end today's class, and then I will talk about the ceramic matrix composites in the next class. So, basically what have we discussed so far is that we discussed about what is composite material, the basic definition, and what are the basic characteristic composite materials. Okay. We discussed about their fundamentals and properties, and we discussed about the classification of composite material in terms of matrix. We discussed that there are three kinds of composite materials if we try to divide them in terms of matrix. One is metal matrix, then we have ceramic matrix, and then ultimately we have polymer matrix composites. And in today's class we talked about metal matrix composites, fundamentals, properties and application. In the next class what we will discuss is basically we will discuss about the remaining portion which we have not discussed is the ceramic matrix composites. Why do you need ceramic matrix composites? Just to give you some basic idea is that ceramics, they have very high strength, right. We all know very well they have very high strength, they have very good elastic modulus, and they have high temperature strength as well. But then why do we need to reinforce ceramics? We will discuss that in the next class. Along with that we will talk about polymer matrix composites, and then we will move into classification in terms of the reinforcement or second phase. Okay. And then we will move into the fibers, their basic methods of synthesis. We will give lot of different kind of examples. We will talk about glass fibers, Kevlar fibers as the classes goes on. Okay. So, with that I think I end here today's class. Thank you all for listening me patiently, and we will meet in the next class. Thank you all again.